Have you ever written code that works perfectly with 10 items but completely crashes or freezes when you test it with 10,000? That is not a bug, that is an efficiency problem. Today, we are not just learning to code, we are learning to measure how scalable our code is using algorithm runtime analysis. By the end of this video, you will understand big O notation and why it is the single most important concept for technical interviews. First, let us clear up a misconception. When we talk about runtime analysis, we are not counting seconds or milliseconds. Why? Because different computers have different speeds. Instead, runtime analysis is about growth. We want to know, if I double my input data, does my runtime double? Does it quadruple? Or does it stay the same? Efficient code stays cool under pressure. Inefficient code might work fine for small tasks, but it suffocates when the data gets large. Think of your algorithm like a car's gas mileage. Its performance depends on the condition. Like first one is the highway driving, which is the best case. You are cruising, no traffic. This is the minimum work required. In algorithms, we call this the best case. Second is the mixed driving, or you can say average case. Some traffic, some open road. This is the typical scenario you usually face. Third is the city driving, or the worst case. Stop and go traffic. Red lights everywhere. This requires the maximum amount of work and fuel. This is the worst case. In computer science, we use three Greek letters to describe these scenarios. First is omega. This represents the lower bound or the floor. It guarantees the minimum time your code will take. Basically, your best case scenario, like highway driving. Second is theta. This is the tight bound or the average. It gives you a realistic performance expectation. And finally, the most famous one, big O. This represents the upper bound. Why do interviewers care so much about big O? Because it guarantees the maximum time. It is about risk management. If you know the big O, you can prevent server crashes during traffic spikes because you know exactly how bad things could get in the worst case scenario. Let's look at a real example. Linear search. Imagine we need to find the number 4 in this list. In the best case, that is in omega, the number 4 is right at the front. We find it instantly, that is omega 1. In the average case, in theta, we might look through half the list to find it. But in the worst case, big O, the number is at the very end or not there at all. We have to check every single box. If we have n items, we do n operation. This is big O n. Here is a quick pro tip for interviews. If you calculate your complexity as big O 2n plus 5, just call it big O n. We drop the constant because we only care about the trend. As n gets massive, that 5 plus 5 doesn't matter anymore. Now let's look at a faster algorithm, binary search. This only works on sorted list. Instead of checking every number, we check the middle. If our target is lower, we throw away the entire right half. We keep dividing the problem in half. This is the divide and conquer strategy. Because we cut the problem in half every time, the complexity is big O log n. This is much faster than linear search for large data sets. Let's visualize this. On this graph, the x-axis is your input size and the y-axis is time. See this flat green line? That's big O1. That is perfect scalability. So this blue line, that is big O-N, it grows steadily. But see this red curve shooting up like a rocket. That is big O-N square. We call this the danger zone. This usually happens with nested loop, a loop inside a loop. If your code lives here, it will crash your system when your user base grows. Remember, the goal of a great software engineer is not just to write code that works, it is to write code that scales. We want flat curves and happy users.